Hello, so am I audible? Nabil, Alia, Arpit.
Yes, sir.
Yes, sir.
Good evening. Okay. So we were doing Kirchhoff law in the last class. Let's recall what was Kirchhoff laws. So Kirchhoff gave two laws. What was the first law of Kirchhoff, Arpit?
Yes, sir. So can you repeat, sir?
Yes, I'm saying which was the first law of Kirchhoff? Kirchhoff first law. What was Kirchhoff first law?
Sir, it states that the current entering the junction and the current leaving the junction is equal.
Okay, we used a sign convention in that law. Kinza, what was the sign convention that we
I2 plus I3
Yes, yes. Kinza, what was the sign convention that we use in Kirchhoff junction law? We wrote a sign convention also.
Yes, sir. The current entering will be taken as positive and the current leaving will be taken as negative.
Good, good. Then we did Kirchhoff loop law. What was loop law, Maharaj? Kirchhoff voltage law, Kirchhoff loop law. Maharaj Rahman.
So it was based on the conservation of energy.
Mhm.
So it is the algebraic sum of all voltages.
And how much is that
In a
algebraic
closed
sum
loop,
of all
that
voltage?
is zero. That is zero.
That is 0. We discussed the sign convention also. Minashi, what was that
Yes,
sign
sir.
convention?
Rise in potential is positive and fall in potential is negative.
Yeah, rise is positive and fall is negative. So, fine. Then we did this thing also, na? Like if you have a cell, then if you go from higher to lower terminal of the cell, the EMF is negative. If you go from lower to higher terminal of the cell, EMF is positive. And the resistor, if you are going in the direction of current, that voltage drop is negative. If you are going in a direction opposite to that of the current, then voltage drop is positive. And then we did this example, like if you have a loop, if you add up all the voltages, that comes out to be 0. Then we discussed, we have started this numerical, we will not finish it. Okay, we'll continue with this numerical. Akshay, you were again absent in the last class. What happened?
Yeah, I was traveling. I'm in India right now, so
Okay, you were traveling. Did you went through the recording?
I didn't receive it.
You should check your student's account.
Yes.
The lecture recordings get updated within 24 hours usually.
Okay.
So in the video section of your student account, you should get the record. Are they getting updated regularly? If anyone is checking, Alia, Nabil?
Excuse me, sir.
Yes, Arpit.
Sir, I am facing some issues in that app, sir. So like, I don't get any notification or assignment or something. And sir, it is always written that it is expired or something. And this is the issue.
Is it still showing? Okay,
Yes, sir, I have told the
let's
team
at the end
several
of the
times,
class.
like it's persisted.
Let's discuss this at the end of class also. We'll discuss it.
Okay, sir.
So I will take someone from the operations team in the meeting and we'll discuss it at the end of the class.
Okay, sir.
Okay, so let's start with this numerical. We have already discussed the division of current in the circuit. So how many we started with, so this was the circuit, given circuit. This is cell of 2 volt, its internal resistance 1 ohm. I'm just recalling the question. This is cell of EMF 5 volts, its internal resistance is 2 ohm, and this is resistor of 5. Some current I1 is coming out of this cell. There is no junction, there is no branching, so the current does not divide. The same current I1 is flowing up to here. Then there is a junction, so current will divide into two parts. Current I1 is going through this 5 ohm resistor, and the remaining, like I1 minus I2, is going through this resistor. It passes through the cell, passes through the resistor. Then again, no branching, so it will not divide. But if you look at this point C, then some I2 is current coming from point D, and some I1 minus I2 is coming from point F. Then they combine, and they form current I1. And this current I1 will again go back into the cell. So we have discussed that the current that comes out the cell should enter. If the current which is coming out of the cell is same as that of the current which is entering the cell, that means your division is correct. We have also discussed that the division is not unique in the circuit. You can have many types of division. We consider one more division, that if you start this cell, then we can also take this division. So you can solve the circuit using this division, or you can solve the circuit using this division. You will get the same answer. When I'm saying the same answer, that means I'm not saying that I1 and I2 will be same. I'm saying if current 5 ohm, the current passing through is 5 ohm through this division will be equal to the current passing through the 5 ohm in this division. Similarly, the current passing through this 2 ohm in this particular division will be same as that of 2 ohm. Means I1 of this division and I1 minus I2 of this division would be same. Fine, you can choose any of the division. Is it clear, everyone? You want to discuss something? Then we'll start with the calculations. Nabil, Akshay will face some issues today.
Yes.
Miraj, Minashi, Saifullah, Ishika, clear? Noha,
Yes, sir.
it's okay.
Yes.
So now, so let's just count the number of variables. Arpit, how many variables are there?
Sir, two.
Two variables. One is I1, another is I2. So for two variables, we need two equations. For two equations, we need two loops. So we can choose any of the two loops. You can choose any of the two loops. In the second step, so we have two variables. Two variables. We will choose two loops. Two variables means we will choose two loops. Two variables and two loops. So we have these two loops. See the total number of, can you just count the total number of closed loops that we have? Just try counting the total number of closed loops that we have. Yes. Will anyone tell me the number of closed loops, total number of loops here?
Sir, two.
Two. Okay. There's just two loops, or anyone can see more, three loops also? Nabil, Ahmed, there are only two loops or three loops?
Sir, outside, sir, the whole
Three loops, sir.
Three
circuit.
loops.
Sir,
Three
there
loops.
are
See,
three.
one is ADCBA, another is BEFCD, another is ADEFCB. So you have three loops. So what you can do is you can choose any one of these three loops. Sorry, not one. We need two loops, and any two of these three loops. So I will consider this ADCBA. So we choose loops ABD. After choosing loops, what we will do in the step 3, we will write equations for KVL. We'll use KVL to write equations. So I'm considering this particular loop, ADCBA. ADCBA. This is the loop, ADCBA. So let's say you are moving in this. You can start from anywhere. Like I'm writing it from A. So let's start with A. I'm going from A to D. Nabil Khan, what will be the voltage drop across this 10 ohm resistor? I'm going from A to D now.
I1 minus I2.
No, see AD. What's the current passing through this 10 ohm
I1,
resistor?
I1.
I1. And what would be the voltage drop?
1.
Minus 10.
Minus 10 I1. Nah? You're going in the direction of current. When you're going in the direction of the current, then voltage is negative. We discussed this in last class also, Nabil. Minus 10 I1. Nabil Khan, again, let's move from D to C. How much is the voltage drop here?
Minus 5.
No, 5 is the resistance. Voltage is 5 into current, right? Tell me, Nabil. 5 I2, right?
Yes, sir.
Minus 5 I2. No mistake now. Let's tell me the voltage across the third one. So there is no resistor here. This is 1 ohm. What is the current which is passing through this 1 ohm resistor?
I1.
I1. And when we are going from B to A, right, we are going from B to A, see, B to A. Then we are going in the direction of current or opposite to the direction of current?
In the direction of current.
Okay, when you go in the direction of current, then voltage is positive or negative?
Negative.
Negative. So what would be the voltage?
-1.
Minus
I1.
1. Then let's move on to this. You're going from negative to positive. This is rise. So how much will be the voltage if you're going from negative to positive? Minus
Plus
2 or
2.
plus 2?
Plus
2.
2.
So rise in potential. Plus 2 equal to 0. Is it clear, everyone? Alia, Anshika, Hishma, Yashika. Is this equation clear for everyone?
Yes, sir.
It's okay. Now let's combine them. This is minus 10 I1. This is minus 1 I1. How much is minus 10 minus 1? Minus 11
It's
I1
11.
minus 5 I2 plus 2 is equal to 0. Let's call this as equation number 1. So you have one loop, one equation. Let's move on to another loop. So let's take this loop, D, E, F, C, D. See the first loop, A, D, C, B, A. We take this loop to be clockwise. It's your choice whether you want to take clockwise or you want to take anti-clockwise. You choose first loop to be anti-clockwise. You can not clockwise or anti-clockwise. This is clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. No? So we can take the second to be clockwise or anti-clockwise. That's your choice. Now let's take this to be clockwise. Let's move from D to C, then F, then E, then again D. So I'm choosing the loop DC, D, C, F, E, D.
Can't we choose D, E, F, C, D?
Which one? Yeah, I can
D,
even
E,
choose D, F, C, D. Yes, I can even choose any loop. They won't change the equation. We have discussed this thing earlier also. Now, if we change the loop, then the equation will change just by a negative sign, nothing else. Okay.
Yes.
Okay, now let's. When you go from D to C, what is the voltage drop, Saifullah?
From where to where, sir?
D to C. I'm going from D to C. What is the voltage drop here?
5I2.
5I2. Plus 5I2 or minus 5I2?
Minus.
D to C, Saifullah. You're going in the direction of current. It's positive.
Minus.
Or negative? Good, Alia. Minus 5I2. It's minus 5I2. Now let's move from C to F. You're going in the direction of current, opposite the direction of current. Opposite, na? Current is going from F to C. We are going from C to F, opposite to the direction of current. So what will be the expression for voltage drop, Mehraj? C to F, I'm going. Mehraj.
So can you repeat the question?
I'm saying we are going from C to F. So what will be the voltage drop? It will be positive, negative. What will be the voltage drop?
So it will be negative, right?
Positive.
No, when we go in a opposite to the direction of current, and voltage drop is positive. See, here we are going in a direction opposite to that of the current, so voltage drop is positive. So Mehraj, tell me again. You're going from C to F in the direction of current or opposite to the direction of current?
So you're going opposite.
Opposite. So voltage drop would be
Minus
plus,
5.
plus.
Sorry. The
When you
plus.
go opposite to the direction of current, it's positive. 5. Then we're going from F to E, Kinza. This 2 ohm resistor, you're going in the direction of current or opposite to the direction of current? Kinza. From F to E, you're going in the direction of current or opposite to the direction of current? Kinza is not in meeting. Huh? Minashi, tell me. We're going from F to E in the direction of current or opposite to the direction of current?
Opposite of the current.
Opposite. So what would be the voltage drop?
Plus 2.
minus
2 into I1 minus I2.
Resistor I1 minus I2, na? This is I1 minus I2, which is passing through this resistor. This is the direction of current. We are going from F to E, opposite to the direction of current. So it's plus 2 minus I2. Hishma, you're going from this higher to lower terminal. It's rise or fall?
Fall in potential.
So it will be plus 5, minus 5?
It will be -5.
Minus 5. So it's minus 5 is equal to 0. So you have minus 5I2 plus 5I1 minus 5I2 plus 2I1 minus 2I2 minus 5 is equal to 0. So we have minus 5I2 minus 5I2 minus 2I2. How much is it? 5, 5,
1
10,
question.
12. Minus
Sir,
12.
how do you get the -5 at the end?
Minus 5 is because we are going from F to E. So when we are going from F to E, then first the higher terminal, then the lower terminal of the cell. It's
Okay.
fall. Fall is negative. So minus 12I2. Next we have 5I1 and 2I1. That's 7I1.
7.
Then we have minus 5, which is equal to 0. Is it clear? Noha, Uneep, Anshika?
Yes, sir.
So this was physics. Now you just have to solve these two equations and get the value of I1 and I2. Now let's solve this equation. Let's solve equation number 1 and 2. Let's solve 1 and 2. So 1 is this minus 11I1.
Sir, you won't count ED here.
So which one? Sorry.
ED, sir, in the diagram. Like
In the-
from E to D, we won't move, sir.
E to D we will move, but there is no resistor in E to D. There is no cell, no resistor. So there won't be any voltage.
Okay, sir. Only those which are having either cell or
A cell or a, because we are adding voltages. So for voltage, we need something. So from E to D, you have a straight wire. The resistance of the wire is 0.
Okay, sir.
So even if you multiply it with I, you will get 0. 5I2, what is next? Plus 2 is equal to 0. Then we have the 7I1. I'm just changing the order. 7I1 minus 12I2 minus 5 is equal to 0. Yashika, how to solve these equations? 7I1. Easiest method to solve this equation.
Subtract.
No.
Multiply the first one by 7 and the second one by 11.
Yeah, this will be the easiest one. Elimination. If you subtract them, then nothing is getting cancelled out here. So when you multiply it with 7, this would be minus 77I1 minus 35I2 plus 14 is equal to 0. That's my first equation. Then you have 77I1 minus 11 into 12. How much is 11 into 12? 120 and 12, 132. 132I2 minus 55 is equal to 0. Now we can add them up. They get cancelled out. So minus 35 minus 132, that is minus 167I2. And this is minus 55 plus 14. So how much is it? It's 45, 41. So I2 is, it's 41 by 167 with a negative sign. So this will remain as it is, no cancellation. This much of ampere. Now see, after calculating I2, let's calculate I1, and then we will discuss the significance of this negative sign. Let's call this as equation number 3, We can substitute this 3 into any one of the equations. Let's substitute this in this one. So when we substitute 3 in 1, what we get is minus 11I1 minus 5I2. I2 is minus 41 by 167. And then minus 5 is equal to 0. So we have minus 11I1 plus 205 by 167 minus 5 is equal to 0. So yours minus 11I1 is 5 minus 205 by 167. So this is 167 into
Sir,
5.
isn't the last term 2, sir?
Sorry, last one was 2. No, it was, yes, it's 2. Thank you. Plus 2. It's plus 2. It's plus 2. It's minus. So you can get the value of I1 from here. Is it clear? So your I1 will be positive. So what's the significance of this negative sign? This negative sign simply shows that the actual direction of I2 that we have assumed here, we assume that I2 is going to the right hand side, but the actual direction is not to the right hand side. The actual direction is to the left hand side. So this negative sign shows that direction of current is opposite. It's opposite to the one we have assumed. This is right. This is the significance of negative sign. So don't have to change anything. It doesn't mean that you are doing it wrong. It simply means the actual direction is just the reverse that we have assumed. See, here we are assuming the direction of current. We don't know the exact direction. We just assume, okay, I2 is going to the right hand side. This is our assumption, but the actual direction could be reverse of it also. So is it clear, everyone?
Yes, sir.
Okay, do it. So
सर अगर दो लूप है तो फिर दोनों में सेम डायरेक्शन लेनी होगी या फिर कोई भी ले सकते?
You can take any direction, like clockwise, anti-clockwise, anti-clockwise, anti-clockwise. That's your choice. You can take any combination. That doesn't matter. So first part is over. We have current through each resistor. Just note it down. Then move on to the next part of the question. And it would be better if you do it on yourself. Don't just copy the calculations. You won't learn anything.
Sir, can you scroll up for a minute
Yes.
for the diagram?
Okay.
Done, sir.
Sure.
Just scroll.
Just scrolling. Nabil Khan, is it clear now?
Wait a minute. Can you go up?
Yes, I can scroll.
No. Can you go to step 2, sir?
Step 2, yes.
Written. Can you move on to the next part of the question? Ishma, Mashi.
So just a second.
Sir, can we go a little up?
Yes. Let's try to finish this chapter. It's 2 topics left.
Alia, doubts?
So can you scroll?
Yes. Kinza, is it clear? All steps?
Yes, sir.
So scroll.
Yes. So did anyone calculated I1? Did anyone calculated I1? I1 is 17.
939 by 1837.
Okay. Plus 205. 539, huh? It's 539 divided by 11 into 167. 1837. I'm converting this in decimals. See, usually when you do questions of Kirchhoff law, you get these type of answers, these type of absurd answers. So it's better to convert it in decimal. If I convert this thing in decimal, 539 divided by 1837. So it's 0.2934. 0.2934. So if I round it off, it comes out to be around 0.3 ampere. See, since I'm just rounding it off, so it will have some error in the calculation, but I'm just ignoring that sort of error. Actually, it won't be 49, na? Okay, you can further cancel out.
By 11.
No, sir, it's 0.2.
Okay. So let's take this in that form. Don't take it in decimal. Because if either we take it up to 4 decimal place or it will get cancelled out as 11. 11 fours are 44. And then you have 99. Okay, 11 nines are 99. 11 167. So that's the first part of the question. Now we know current through each resistor. So everyone have written? Akshay, written? Yashika, Arpit?
Yes.
Yes, sir.
Okay, now let's move on to the next part of the question. The second part says you need voltage drop across each resistor. Say I'm not calculating voltage drop across each resistor. I'm just calculating voltage across one or two resistors. Like I'm calculating voltage across this 1 ohm. That's the same thing. Now I will be repeating one thing by one. So it's 1 ohm resistor. We'll calculate voltage across 1 ohm. And let's calculate voltage across this 2 ohm resistor. So in the second part of question, I need voltage across 1 ohm. So Alia, what will be the expression for calculating voltage across 1 ohm? What will be the voltage across 1 ohm? Alia. Voltage across 1 ohm. Kenza. Voltage across 1 ohm. Expression for calculating voltage across 1 ohm. Kenza.
Minus I1. I1.
Yeah, voltage will be 1 into I1. Huh?
Yes.
Voltage will be 1 multiplied by I1. And how much is I1? I1 is this 49 by 169. So it's 49 by 167 volt is the voltage across I1. Let's call this as V1. In the next part, let's calculate voltage across 2 ohm resistor. So if I ask you to calculate voltage across this 2 ohm resistor, what will be the expression of voltage across 2 ohm? V2. This is IR2, not IR2. Ishma, what is the current passing through this 2 ohm resistor?
2 into I1 minus I2.
2 into I1 minus I2. So the voltage across this is 2 into I1 minus I2. So it's 2. How much is I1? I1 is 49167 minus I2 is this minus 41 by 167. Minus 41 by 167. So it's 2. When they added up, the LCM is 167. This is 49 plus 41. So 9 into 2, 180.
Sir, you're not audible.
I'm not audible. Arpit, am I audible now?
Yes, sir. So you were paused for a second.
Okay, sorry. So is it clear? This second part, voltage across 2 ohm resistor?
Yes, sir.
See, it's a very, very lengthy question. Basically, I have mixed several questions. These are 5 questions, so I have mixed all in one. Next, we need power dissipated across this 5 ohm resistor. This is the 5 ohm resistor. How to calculate power across it, Minashi? How do you calculate power across this 5 ohm resistor?
I square I1.
Sorry. What expression you will use for power?
I square.
I square R, right? Yes. So for power across 5 ohm resistor, power across 5 ohm resistor, we will be using this expression. Power is I square R. So how much is I? I is, what current is passing through this 5 ohm resistor? I2 is passing through this. So this is I2 square into this 5 ohm. And how much is I2? I2 is this minus 41 by 167. So it's minus 41 by 167 square multiplied by 5 watt. Clear? Is it clear, everyone? Hishma,
Yes.
Miraj, Nabil Khan, is it clear? This power dissipated?
Yes, sir.
Yes, sir.
Now, the next part is bit tricky. Huh? This type of questions are tricky. Potential difference between A and F. So to calculate potential difference between A and F, what we will do is, we will start from A and we'll go up to F through any route. And we'll keep on adding all voltages which lie in this. So from A to F, we can either go from A to B, then B to C, then C to F. Or you can go from A to D, D to E, D to F. Or you can go from A to D, D to C, C to F. It does not matter what path you choose. You will get the same answer. So I'm choosing this route, A, B, C, F. using loop, not loop, path. I'm choosing an open path. A, B, C, F. So what you are supposed to calculate? You are supposed to calculate potential difference between A and F. Potential difference means he's asking you to calculate VA minus VF. You need VA minus VF. So to calculate VA minus VF, what we will do is we will start from this point A. The potential point of point A is VA. Then we will move from A to B. When you are going from E to B, you have a cell and a resistor of 1 ohm. When you go through this cell, you are going from higher to lower terminal. That's fall in potential, which we take as negative. Then again, there's a 1 ohm resistor. Current is going from B to A, but you are going from A to B. You are going in a direction opposite to the direction of current. So the voltage drop will be positive. So it will be 1I1. Then again, you're going from B to C. There is no voltage, no potential difference across B, in between B and C. Then you go from C to F. When you're going from C to F, there is a voltage across 5 ohm. The voltage across 5 ohm is 5 into I1 minus I2. But since you are going in a direction opposite to that of the current, you will get it's plus 5 I1 minus I2, which is equal to 0. This is 5 I1 minus I2. You are going in a direction opposite to the direction of current. 5 I1 minus I2 is equal to 0. And you have just one more thing. You have F. You need VA minus VF. So we'll write this as minus of VF is equal to 0. So from here, you can write that your VA minus VF is, you can take all these terms to the right hand side and you will get 2 minus 1 into I1 plus not
Sir, why
plus.
did you take VF as negative?
Because we need potential difference between A and F. Potential difference between V and F is VA minus VF.
Yes.
I1 minus I2. Next, what we can write this as VA minus VF is 2 minus 1 into I1. How much is I1? I1 is this 49 by 167. Minus 5. I need I1 minus I2. I1 minus I2, we have already calculated its how much? 90 by 167. So this is 2 minus 49 over 167 minus 5 nines are 45, 450 by 167. So your VA minus VF is, it's 2 into 167 minus 49 minus 450. It comes out to be minus 165 by 167. So that is your VA minus VF. It's much of it.
Sir, can you show that circuit for a second?
Yes.
Yes, sir. Thank you. Yes,
Okay.
yes.
So this is how we calculate potential difference between any 2 points. So in the next part is asking you to calculate potential difference between B and E. This is point B and this is point E. You need potential difference between B and E. That's the 5th part of the question. You need potential difference between B and E. How to calculate potential difference between B and E? It's VB. You can start from B. It's VB. We can move through any path. We can go from B to C, C to F, and to E. Or you can go from B to A, then D, then E. That's your choice, what path you want to choose. Let's go it from B, A, D, E. In all paths, you will get the same answer. So I'm choosing the path BA DE, this path. BAD. When you go from B to A, you have this resistor 1 ohm. You're going in the direction of current, so voltage drop will be negative. So you will have VB minus 1 into I1. Then if you look at this cell, you're going from lower to higher terminal. When you go from low to high, it's rise. So it's +2.
Sir, can you say how you got 1 into I1 again?
Yeah, because see, this is the circuit. Huh? This is 1 ohm and this is I1. You need voltage across this 1 ohm. Nah? From B to E, you have to add all voltages will lie on the path BADE. So across this 1 ohm current I1 is flowing. So the voltage is 1 into I1, right?
Okay, sir. Yes.
Then you go from lower to higher, it's rise. We take +2. Then you go from A to D, you're going in the direction of current. So it's minus of 10 I1. Then again, you going from D to E. There is no resistor here, so no voltage drop. But it's E, so it's minus of VE equal to 0. So you can write this VB minus VE as it's I1 minus 2 plus 10. Right. So yours VB minus VE is, the current passing through this 10 is I1 only, na? Yes, it's I1. So it's 11 I1 minus 2. You can substitute the value of I1 here. The value of I1 is 49 by 167. So it's 49 over 167 minus 2. This much of volt is your VB minus V. This is it. You can subtract it and multiply it. So these are the quantities that one can ask you to calculate in a circuit having in circuit of Kirchhoff law. Start writing and tell me if you have doubt in any part. Unib, clear all parts?
Yes, sir.
Kinza,
Yes, sir. Clear.
Nabil Khan,
Yes, sir.
Arpit, doubt in any part, any section?
So,
And please write fast, huh? There is one more type of question on Kirchhoff law. I have to finish it today.
Sir, could you show the final answer of the first one?
Final answer of which one?
Answer. Last one, sir. That fifth one.
Just coming. Everyone have written up to here, up to second part? See, in current electricity, this Kirchhoff law is a very important topic. Very, very important, Kirchhoff law. Can I scroll it? Written, everyone? Anshika, Ishma, written? Someone is writing.
1 minute.
Okay. Just tell me once you have written, huh?
Yes, sir.
Let's move on to the next part. Next
So
question.
1 minute, could you just show that part at work?
Which one? This last one?
Yes, sir. None, sir.
Okay. Okay. So in the last question, what we have calculated current, we have calculated voltage, we calculated power, we calculated potential difference between any two arbitrary points. Next, what we can calculate is we can calculate equivalent resistance also using this Kirchhoff law. So then the next question, we will calculate R equivalent. We will be calculating equivalent resistance using Kirchhoff law. R equivalent using Kirchhoff law. Now to calculate R equivalent using Kirchhoff law, the relation is, see, when we use Kirchhoff law to calculate equivalent resistance, when you don't have series and parallel combination. See, we calculated equivalent resistance using the rules of series and parallel combination. What if you don't have any resistor in series or in parallel? If you can't find series and parallel combination, then we will use Kirchhoff law. And to calculate R equivalent using Kirchhoff law, the method is we will calculate total voltage across the circuit. And then we will divide it by total current. This ratio of total voltage and total current is R equivalent. This is how we calculate equivalent resistance using Kirchhoff law. Total voltage by total current. Ratio of total voltage and total current is equivalent resistance. I'm repeating again. So you don't have any resistor in series or in parallel. You don't have series and parallel combination now. Let's take this example.
Sir, if there is series and parallel, will this still hold true?
Then also it will hold, but then you won't use this method because very, very lengthy. When you have series and parallel combination, then you will prefer the rules of series and parallel combination. But still you can use Kirchhoff law, but Kirchhoff law is something very lengthy. Yeah. So we use Kirchhoff law when you don't find series and parallel combination. Although it holds good for circuits having resistors in series and parallel also, but usually we don't use it.
So the answer remains same, right?
Answer will remain same, yes. See, if I give you one example, just because you ask, see, you have two resistors. Huh? You connect it to a cell of 10 volt. This is 2 ohm. This is 3 ohm. What is the equivalent resistance? 2 plus 3 equal to 5. But if you want to calculate this equivalent resistance using Kirchhoff law, so what you will do is you will take division of current. You will say some current I, and same I goes through it, I goes through it, I goes through it, I goes through it. Then we'll write the equation using KVL, that voltage drop across this 2 ohm is minus 2I. Then across this 3 ohm is minus 3I. Then we'll say you're going from lower to higher, then it's plus 10 is equal to 0. Then you will say, okay, minus 5I plus 10 is equal to, sorry, it's 0. Then you will calculate I, which comes out to be 2. Then we'll say R equivalent is total voltage, which is 10 by total current, which is 2, 5. You got the same answer? But which one you would prefer? Series and parallel combination or the Kirchhoff law?
Series and parallel.
Series and parallel combination. But it holds in all circuits. But if you have circuit like this, R, 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 R here, R here, R. So this is the circuit. Let's name this cube as something. This is A, B. How many resistors are there, Kinza? T
16.
16. 4 4 12 na?
Yes, sir, 12.
We have
12.
12 resistor, not 16. Then you are supposed to calculate R equivalent across diagonally opposite ends. So you need to calculate R equivalent across diagonally opposite ends. So these are the diagonally opposite ends, these two. Diagonally opposite ends. So this is current I. So if you look at this circuit, you won't find any resistor in series or in parallel. There's no series and parallel combination. So this is some current I which is passing through it. Then you can divide this current. See, this current will divide into 3 equal parts. So Hishma, what current will pass through this resistor? Over this junction, you have 3 paths. So current will divide into 3 parts. What current will pass through this resistor? Hishma,
I2.
how much? This is I, it divides into 3 equal parts. How much will pass through this R? Hishma.
I1.
Oh. Anshika, some current I is entering this point A. Then it divides into 3 equal parts. How much current will pass through this R?
Sir, I/3.
I by 3. Right, Hishma? It's dividing into
Yes,
3
sir.
equal parts. No? So it will be I by 3. It will be I by 3. And it will be I by 3 here also. Current divides into 3 equal parts. And over this point, you again have 2 paths. One is going towards C, another is going towards F. Nabil Khan, which current will pass through this R?
Sorry, sir.
See, some I3 current is entering to this point B. Huh? Then this current will have 2 paths. One is going towards F, another is going towards C. So this current will divide into 2 parts.
Yeah, I3 divided by 2.
I3 divided by 2. And how much is it? I by 6?
Yeah.
I by 6 will pass through this R. And yes, I by 6 will pass through this R. Similarly here at point D, the current will divide into 2 parts. Arpit, what current will pass through this R? It's I by 3. Arpit, what current will pass through this R resistor? Good idea. No. Arpit. Akshay, some I by 3 is entering to this point
Yes, sir.
D. It divides into 2 parts. So what current will pass through this R?
I by 6.
I by 6. And through this R?
I by 6.
I by 6. Now, the same will happen here. I by 3 is entering here. It will divide into 2 parts. So it's I by 6. It's I by 6 here. Now, let's see this point H. So two currents are entering over this point H. One is coming from E and another is coming from D. So what's the total current which is entering this point H?
I by.
See, I by 6 plus I by 6. How much is it? This will be I by 6 plus I by 6, which is I by 3 now. Similarly here at point F, I by 6 is coming from B, I by 6 is coming from E. Both the currents will combine here and you will get I by 6 plus I by 6, which is equal to I by 3. Same thing will follow here. See, from C, some current, is there any current coming from C? Yes, I by 3, same will happen here. I by 6 and I by 6 will combine to give I by 3. I'm writing I by 3 directly. Finally, this is point G. Mehraj, how many currents are entering at point G? Mehraj, Rahman.
3.
3 currents. And what are they? I by 3?
I by 3.
I by
3 and
3, I by 3. And this will be I by 3 plus I by 3 plus I by 3, and it will be I. So the total current which is entering here is I. The current I will go here, and the current I will go here. Then it's the same current which left this cell also enters the cell. So that means our division is correct. You're supposed to calculate R equivalent. To calculate R equivalent, we'll need total voltage and total current. Say total voltage is the EMF of the cell, let's say E. And what is the total current which is passing through this cell, Saifullah? Saifullah, what is the total current which is going out of this cell? I. So R equivalent will be EMF divided by I. See, this I is unknown. How many variables we have in this whole circuit? Minashi, how many variables we have in this whole circuit?
1.
One variable.
2.
2 variable. And what are those variables?
I and
I and
R.
R is given resistor. So R is not a variable. R is given. The resistance R is given. You can calculate your answer in terms of R. It's not an issue. Yes, now tell me. Number of variables. Arpit was correct. Just one variable. There is one variable I. See, R is given. So to calculate one variable, you need one equation. So for one equation, we need one loop. I am choosing this particular loop. I am choosing this loop. A, D, H, G. Then it comes back to this A. Let's name this point as some A, B, C, D, E, F, G, H, I, J, K. Let's choose this some K. So I'm choosing this loop. I'm choosing the loop A, D, H. Mehraj, G, K, A. Okay, I'm choosing this loop. Let's write equation for this loop. I'm going from A to D. Who will write this equation? Anshika, just tell me the equation of the loop. We're going from A to D. What will be the voltage drop? Anshika, write equation for this loop. ADHGKA. I'm going from A to D. What will the voltage drop here? Akshay, you will try.
It's negative RI by 3.
Negative I by 3R. Very good. Then we are going from D to H. What will the voltage drop? Negative I by 6R. Then we are going from H to G. It's I by 3. It's R. You're going in the direction of current. So it's minus I by 3R. Then it's E. Lower to higher, it's rise plus E equal to 0. So I can take this E to the left hand side and I take LCM as 6. So it will be minus 2IR minus IR minus 2IR. So it's minus 5IR is equal to minus E. So minus will cancel this minus. Its I is, it's 6E divided by 5R. This is I. 6E by 5R. Now you have current also, so you can easily calculate R equivalent. So what will be the R equivalent? R equivalent will be total EMF. Total voltage, which is EMF, divided by total current I. So EMF is E. Total current is this 6E by 5R. E will cancel this E and you will have 5R by 6. This is the R equivalent across the circle. So this is how we calculate R equivalent if series and parallel combinations are not given. Again, another application of Kirchhoff law. Note it down and tell me if you still have doubt. It would be better if you write this example also. Huh? You can compare like why series and parallel combinations are sort of a shortcut trick for calculating series and parallel. So if you can find series and parallel combination, then always use the methods of series and parallel combination. But if you can't find series and parallel combination, then always use Kirchhoff.
Sir, can you just show the last answer once? This one, sir. This one's final answer.
Yes, this one is final answer.
No, sir. Like this
Okay,
question.
this question's final answer. 5R by 6.
Okay, sir.
Tell me if you have written and scroll it down.
Answer.
Is it clear?
Done, sir.
Okay. So these are some applications of Kirchhoff law. Okay, next we will do Wheatstone bridge. See, Wheatstone bridge, when we do Wheatstone bridge means we have already discussed Wheatstone bridge. Huh? Wheatstone bridge is combination of 5 resistors. It's a combination of 5 resistors. We have one resistor R, another resistor, let's say R1, another resistors R2. This is R3. This is R4. This particular resistor is R5. We connect this system to a cell. The EMF of the cell is. This is what we call Wheatstone bridge. As we have already discussed, that in Wheatstone bridge, in general, no two resistors are in series or in parallel. No series, no parallel combination. What was the balancing condition of Wheatstone bridge?
R1 by R2 is equal to R3 by R4.
Yes, this is the balancing condition of Wheatstone bridge. So balancing condition means it's R1 by R2 is equal to R3 by R4. This is the balancing condition of Wheatstone bridge that we know. So we have to derive. We have already solved numericals on Wheatstone bridge. We have used this condition several times. Now we will go to the proof of Wheatstone bridge. See, for the proof of Wheatstone bridge, we'll be using Kirchhoff law. Let some current I is going through this cell. Instead of R5, when we do practicals or when we derive something, we connect a galvanometer. So balancing condition means the current through the galvanometer is 0. No current is passing through the galvanometer, right? Balancing condition means Ig is equal to 0. This is what we call the balancing condition for Wheatstone bridge. Ig is equal to 0. Current through galvanometer is 0. So let's take division of current. Some current I comes out of the cell. This is current I. When this current I reach point A, it divides into two parts. Some current I1 is some current I1 is going through R1. So out of I, some goes to R1. Then the remaining is I minus I1. I1 is going here. Then this current will have two paths. Some Ig will pass through the galvanometer. Then the remaining I1 minus Ig will pass through R2. Similarly, I minus I1 is coming from A and this Ig is coming from B. They will combine. And when they combine, you will get I minus I1 plus Ig here. This is I minus I1 plus Ig. And when all current combined at point C, see I1 minus Ig is coming from B. and I minus I1 plus Ig is coming from D, then you have I minus I1 plus Ig plus I1 minus Ig. Ig cancel out, I1 cancel out, you just have I. So the I current will comes out of the cell and the same current is entering in the cell. That means our division is fine. Division is correct. Now we have to prove that that if bridge is balanced, which means if Ig is equal to 0, then R1 by R2 is R3 by R4. To prove this thing, you can take two loops. We can do this ABDA loop. We can take this loop ABDA. We will go in this sense. When we go from A to B, this is the current is I1, resistance is R1, voltage is minus of I1 R1. Then you are going from B to D, resistance is G, current is IG, voltage drop will be minus of IG into G. Then you go from D to A, you are going in a direction which is opposite to the direction of current, and it's plus I minus I1 into R3, which is equal to 0. So if bridge is balanced, then you know that Ig is equal to 0. Put Ig equal to 0 here. You will have minus of I1 R1 plus I minus I1 into R3 is equal to 0. So you have I minus I1 into R3 is equal to I1 R1. That is equation number 1. Similarly, you can choose this loop BCDB. BCDB. So when we go from B to C, you are going in the direction of current. So voltage will be positive or negative, Akshay? B to C we are going. Voltage will be positive or negative?
Negative.
Negative. So it's minus of resistance is R2, current is I1 minus IG, minus of I1 minus IG multiplied by R2. Then we are going from C to D opposite to the direction of current. It's plus IG into R4. Then you are going from D to B. You're going in a direction opposite to the direction of current. So it's plus GIG is equal to 0. You can put IG is equal to 0. I made some mistake somewhere. Let's check. When we go from B to C, this is I1 minus IG. So it's I1 minus IG R2, it's fine. When we go from C to D, then this is I minus I1 plus IG, and I take this IG. So when we go from C to D, this is plus I minus I1 plus IG multiplied by this is resistance is R4. Then when you go from D to B, it's minus IG to G, which is equal to 0. Next is if your bridge is balanced, then you can put IG equal to 0. When you put IG equal to 0, you get minus I1 R2 plus it's I minus I1 into R4 is equal minus 0 is equal to 0. This IG will be 0. So we can take it to the right hand side. We get I minus I1 into R4 is equal to its I1 multiplied by R2. That is second equation. Now what we can do is we can just divide 1 and 2. So when you divide 1 and 2, when we divide 1 and 2, so one is this I minus I1 R3 is equal to I1 R1 and I minus I1. So it's I minus I1 into R3 which is equal to I1 R1 divided by its I minus I1 into R4 is equal to I1 R2. So I1 gets cancelled out, I minus I1, I minus I1 will get cancelled out. You have R3 by R4 is equal to R1 by R2. This is how we derive the balancing condition using Kirchhoff. This is again an important derivation. It's not, this calculation is not helpful in numericals, but yes, it's a derivation. It's usually a 3-marker question. Just note it down. Then we'll start our JE and NEET revision.
Yes, sir.
Can I scroll it further? Okay, Noah. Written, everyone?
Yes, sir.
Okay, so that was about Wheatstone bridge. There is just one topic left, which is meter bridge. Then your CBSE syllabus is over for current electricity. Current electricity is over. Just one more topic left, which is meter bridge. Potentiometer is not in a syllabus now. Now let's move on to our J thing. So the last class we were doing capacitors, right? We discussed some questions on capacitor. Those questions were related to this energy of capacitor, and that relation C is epsilon naught A by D. Today we will focus on circuits which have today also we will revise capacitors only, but we will focus on circuits more, series and parallel combination of things. Capacitors, series and parallel. Although most of the circuits which are usually asked in JEE mains in on series and parallel will match with that of the questions that we have did in series and parallel combination of resistors, except few circuits. Like there is one type of circuit related to Kirchhoff law. Kirchhoff law in capacitor. So there are a few circuits which use Kirchhoff law for capacitors. These circuits are not discussed in NCERT, but yes, they can be asked in your JEE and main exams. So just like Kirchhoff law for resistors, we have Kirchhoff law for capacitors. The only difference is in Kirchhoff junction law, KCL, Kirchhoff current law. So there it was Kirchhoff current law, or you can call this as junction. So when you have various capacitors, some Q1 current is entering from here, Q2 current is entering from here, and Q3 current is leaving. So the junction law or the KCL says in current electricity, it says algebraic sum of all the current at the junction is 0. Here it says algebraic sum of all the charges at the junction is 0. Sum of all charges at the junction is 0. So when you add all charges, we consider sign convention. Charges entering the junction are positive and the charges leaving the junction are negative. Q1 is entering the junction, so I consider Q1 as positive. Q2 is entering the junction, so I consider Q2 as positive. But Q3 is leaving the junction, I consider this Q3 as negative. That's the first law. Then the another Kirchhoff law that we use here is loop law. Or we also call that as KVL. This is not in NCERT, it's not included in your CBSE syllabus, but yes, these questions can be asked in your JEE mains exams. JEE mains or NEET exams. So if I take this circuit and I say this is the direction in which charge is flowing. See, there is no resistor here. Instead of resistor, you have capacitor. The voltage across resistor we calculate using IR, but the voltage across capacitor is Q by C. But to consider sign convention, you have to provide polarity to capacitor. See, resistor doesn't have positive and negative polarity, but capacitor have negative and positive polarity. So you have to give some polarity to this capacitor and some polarity to this capacitor. So how we provide polarity? We provide polarity through charge. Charge enters at the positive terminal of the capacitor and it leaves at the negative terminal. So this is how we show. For the first plate is positive, another plate is negative. Similarly here, this plate is positive and this plate is negative. This is how we provide polarity to the capacitor. Then we can apply KVL here. Let's move in this direction, clockwise direction. So when you go from high to low, it's rise or fall. Hello, anyone in class?
Fall.
falls. We take this as negative minus E1. When we go from positive to negative, it's rise or fall? Positive to negative, high to low, it's fall. So minus Q by C1. That's the only difference. In a circuit having resistor, we take IR, but when we take capacitor, it's minus Q by C1. When you go from here lower to higher, it's rise plus E2. We are going from positive to negative, it's rise or fall? Rise, fall.
Fall.
Fall, so we'll take it as negative minus Q by C2 is equal to 0. So that is the difference between Kirchhoff voltage law in resistor and Kirchhoff voltage law in capacitor. Instead of IR, we'll be using Q by C. In resistors, the direction of current was important, but in capacitor, it's the polarity which is important. Note it down, we'll do one question on it.
You say how you got minus 4 Q by C1.
Minus Q by C1, it's because we are going in this direction. When we go in this direction, this is first the positive terminal of the capacitor, then negative terminal. Positive means one at higher potential, negative means lower potential. So we're going from high to lower potential. Okay?
That is fall.
Yes. Please make a separate notebook for this JNEET thing. You'll be having a very clear-cut division of the topics which are in NCERT and the topics which are not in NCERT. So you don't mix them up in your school exams. Can I scroll it now? Please write fast, huh? Can you scroll it now? Akshay? Ishma?
Yes.
Yes, sir. Okay, let's see this example. Huh? You're supposed to calculate potential difference across 1 and 2. See, for these type of circuits, how to decide whether you have to use Kirchhoff law or you have to use series and parallel combination. See, whenever you find two cells in a circuit of capacitor, whenever you have two cells, you can't have series and parallel combination. Just go through Kirchhoff law. Go to Kirchhoff. So in a capacitor circuits, whenever you find various cells in a circuit having capacitors, then just go to Kirchhoff law. So for Kirchhoff law, what was the first step when we were doing solving circuits using Kirchhoff law in resistors? What was the first step?
So direction of current.
We first do division of current. So here, instead of division of current, we will do division of charge. Some charge, just instead of current, I'm writing charge. Some charge comes out of the cell. It goes here, then it goes here, then it goes here. Then you have branches, say some charge, let's name it as Q1 goes through this C, and the remaining Q minus Q1 will go here, then it go here, then it go here, then it go here, then it go here. This is Q minus Q1. Then both the see, Q1 is coming from here, Q minus Q1 is coming from here. They will combine Q minus Q1 plus Q1. Q1 gets cancelled out. You have Q only, and that Q will enter into the cell. So that is the division. How many variables we have, Miraj? Miraj is not in class. How many variables we have here, Minashi? Just count the number of variables.
2.
2 variables. One is Q, another is Q1. 2 variables means 2 equations. We'll take 2 loops. So for the first loop, we write equation using this KVL. Okay, how to decide the polarity, Minashi? Which plate will be positive, which will be negative? This will be positive or negative? This will be positive or negative? Yes. Sorry? This plate will be positive or negative, Minashi?
Negative.
Negative. No. See, the first plate in the direction of charge is positive. Second is negative. Okay?
Okay.
Tell me about this plate. Is it positive or negative? Charge is going upwards. So the first plate in the direction of charge is positive, second is negative. What about this?
Positive.
And this negative. So let's move in this first loop. I call this as loop 1. Loop 1. So when you go from here to here, this is cell. You are going from lower to higher. That's rise plus 2. When you go from here to here, there is nothing. No capacitor, no cell means no voltage drop. When you go from here to here, you're going from positive to negative. It's rise or fall? For rise or fall? Minus q by 2. Positive to negative, that's fall, minus q by 2. When you're going from here to here, you're going upwards. The first one is positive, another one is negative. The capacitance is C. Going from positive to negative, rise or fall, Kinza?
Fall.
Fall. So it will be minus q by C. And we have considered all 1, 2, 3 voltage drop, which is equal to 0. That's my first equation. This is Q1, right? This is Q1 by C. Then let's go in this equation. Let's start from this cell lower to higher, rise. So it's plus 2. Then we go from 1 to 2, negative and then positive. It's rise or fall, Saifullah? First is negative, another is positive.
Rise.
Rise. Good, Alia. So it will be positive plus Q1 by C. And then we go from here to here. It's rise or fall? First positive, then negative. Fall. Minus of Q minus Q1 divided by 2 is equal to 0. That's the second equation. Now, to get the value of voltage across 1 and 2, I need Q1 as well as C. So let's see how can we calculate Q1 from here. I need Q1. So if I add this equation, I somehow calculate Q1. Let's add these 2 equations. So when we add these equations, this and this will cancel. I will be having 4 minus q by 2. And this will be minus of q by 2. Minus minus plus q1 by 2. is equal to 0. We need Q1. Q1 is Q by 2 minus Q by 2 minus Q beta is Q4 minus Q plus Q1 by 2 is equal to 0. So if I want Q1, then Q1 will be. Is there any other method to solve this equation particularly? Okay, note it down. Then we'll solve these equations. Just note it down up here. Do the division of current, then we'll see. Written? Can I scroll it further?
सर वो बीच वाली कैपेसिटेंस कितनी है?
This one? Charge is Q1, capacity is C.
सर गिवन नहीं है कुछ वैल्यू की?
No, no, C is not given. C is not. Can I scroll it further? Then we'll solve the equation. Huh? We need Q1. Hishma, Kinza, Minashi. Can I
Yes, sir.
scroll it now? Okay.
Yes, sir.
Just write these equations. I should not add these equations. I should solve them in a different way. Because we still have two variables. Nah, it's not solvable in this way. Let's plan something else for the equations. Everyone have written up to this equation number 2? Yes.
Yes, sir.
Okay. So let's simplify this equation first, then we'll see how to calculate Q1 from these two equations. So it's 2 plus Q1 divided by C. If I multiply with this negative sign, it's minus Q by 2, and this plus Q1 divided by 2 equal to 0. So our motive is to calculate Q1 somehow. So let's subtract these two equations so that this Q2 gets cancelled out. So C is given. We can calculate our answer in terms of C. We'll try to eliminate Q somehow. So if I subtract 1 and 3, now I will subtract 1 and 3. So when I subtract 1 and 3, what I get, it's negative, it's negative, it's positive, it's negative. So see, this minus Q by 2 will cancel this thing. 2 will cancel this minus Q. Q1 will not get cancelled out. So we will be left with, it's minus Q1 by C. It's minus Q1 by C plus, yeah, now we're getting some result. Q by 2 is equal to 0. Now we can calculate Q1. So minus Q1 and this is Q1 by 2. So this is minus 2 Q1 by C. It's plus Q1 by 2 is equal to 0. I can take Q1 as common from here. So we have 1 by 2 minus 2 by C is equal to 0. Okay, so from here, I get Q1. See, this is in the multiple, so it will go to denominator. 1 by 2 minus 2 by C. and 0 by anything is 0. So what we get Q1 is equal to 0. So if Q1 is equal to 0, that means there is no voltage drop across this capacitor. So if charge is 0, then voltage drop across C kitna hoga? Voltage across C is charged by capacity. Charge is 0, so capacitance is 0. So the voltage drop across 1 and 2 is 0. Is it clear? Nabil Ahmed, Akshay, Yashika.
Yes.
Yes, sir.
So if you find two cells in a circuit having capacitor, then use Kirchhoff law. The only difference is instead of current, you will be using charge. That's it. Instead of IR, you will be using this Q by C. See, I'm not discussing few topics which are for JEE Advanced. We are targeting JEE Mains, up to JEE Mains, NEET and JEE Mains. The best strategy is first try to score 99 percentile in JEE Mains, and once you have qualified JEE Mains in the first attempt, you still have 3 months, 2 months at least. In those 2 months, you can easily prepare for JEE Advanced. So not doing JEE Advanced right now. We are targeting JEE Mains.
So could you scroll down?
Clear, everyone?
Yes, sir.
Okay. Let's so that was about series and parallel combination. We can do one more question on series and parallel combination.
So total charge is 0, sir.
Not the total charge. It's Q1. The charge through this capacitor C is 0. Not the total charge. The charge passing through this C is 0. Not the total charge. So this is the type of circuits that we have not discussed, and there's nothing else left. There are for JEE Advanced topics. Okay, we have discussed Wheatstone bridge for resistors. So let's do one final question on circuits of capacitors. See, this circuit have a Wheatstone bridge hidden. Somewhere in this circuit, there is one Wheatstone bridge which is hidden. You had to identify that Wheatstone bridge. You have to use the balancing condition, and then it's over. And then this is over. C1, C2, C3, C4, C5, C6. All resistors are equal, all capacitors are equal. You are supposed to calculate C equivalent across A and B. There is a Wheatstone bridge hidden here. Find that Wheatstone bridge. Then it's easy. If you can find Wheatstone bridge here, it's easy. All capacitors are equal. I'm waiting for your answers. All capacitors are equal. Solve it. We have discussed this Wheatstone bridge for resistor, the same thing. Same balancing condition. You have to find out of these 1, 2, 3, 4, 5, 6 resistors, which 5 are forming a Wheatstone bridge. And then you will check the balancing condition. See, all are equal, so bridge must be balanced. You have to remove that 5th capacitor. When you remove that 5th capacitor, you will find series and parallel. I'm waiting for the final answer. Good. See, it's an easy circuit if you can just think of 5, can find 5 capacitors. No need. All the values of all is C. Huh? So your C equivalent should be in terms of C. It's not the correct answer. Answers. Okay, let's do it. Is anyone solving this circuit? Yashika? Saifullah, Minashi, Ishma? Is anyone solving this circuit? Or I have to solve? Hello?
Sir, solving.
Solving. Okay. Just try to find the Wheatstone bridge. Draw this circuit and try to find this circuit in this one. We have done several forms of Wheatstone bridge. We did this form also. Na? See, we did Wheatstone bridge for resistors and capacitors, no difference. The circuit analysis is same. Try to find this circuit here. Your cell is connected between here. No, Yashika. Any other answer? Akshay? Stefula? Okay, I'm solving it now. See, if you look at this system, this is making a Wheatstone bridge. This C1, C6 are basically like C1 and C2. This and this are, no, Yashika, no. These two, this is like your capacitor number 1 of Wheatstone bridge. This is like your capacitor number 2 of Wheatstone bridge. This is like your capacitor number 3 of Wheatstone bridge. This is like 4 of Wheatstone bridge, and this is like 5 of Wheatstone. So these 5 are making Wheatstone bridge. And this bridge is balanced. So C1 by C6 is equal to C2 by C5. If they are equal, then you can remove this particular capacitor. You can remove this one. You can remove this capacitor. So when you remove this capacitor from here, now it's solvable. Nabil Ahmed, just tell me which two capacitors are in series.
C1 and C6.
And is there any
C5
other pair?
and C2 and C5.
And what about C? These two are in series. These two are in series.
C4,
And what about
C5,
this? And what about the whole combination?
C25 and C4
Parallel.
parallel, and
T16 is also in parallel. Are you getting this? Minashi, Kinza?
Sir.
C1 and C6 are in series, C2 and C5 are in series, this C4, C2, C5 combination, C1, C6 combination, all are in parallel. So this is C and this is C. If you take series combination of same capacitors, then it becomes C by 2. You can remove them and you can put a single capacitor C by 2. Similarly, C2, C5 are in series. When similar capacitors are in series, it becomes C by 2. And this is C4, which is also C, and they are connected something like this. They all are in parallel. So you have this fourth is C. Sorry. They all are in parallel, and this is point A and B. So your C equivalent is, see, when you ask me to train you for JE and mains, then I assume that you can do all these steps directly. Like if you are writing these steps also, then it's very tough to crack these exams. Huh? Then you can score well in your school exams, very good in boards, but for JE mains, your calculation should be very, very fast. Like I expect that you can do it without even using your pen. C series C by 2, C series C by 2, then C parallel, C plus C by 2 plus C by 2, that's 2C. So that is the C. Note it down. After this, now you can solve any book which have questions on JEE mains. I have skipped few topics which are in JEE advanced syllabus, but for JEE mains, chapter number 1 and chapter number 2 is over. For JEE mains and NEET, it's over. Now, what you should do, you should take out the previous year's questions of JEE mains and NEET, whatever you are preparing for, and should work them out. From next class onwards, I'll do one more question on this series and parallel combination of capacitor, and then we'll start the revision of current electricity. So on Wednesday, we will finish current electricity for your CBSE exams, and we'll start the revision for JEE and that NEET. This is how we'll do for the entire syllabus. So we'll be doing every topic twice. So simultaneously, we'll be revising everything also. Yes, everyone have written this? Okay, so let's stop here. We'll continue this on Wednesday. Yeah? Okay, bye.
Thank you, sir.
Sure, okay.
Thank you, sir.
Thank you, sir.